Hello, my math friends. This is Mrs. Schlecht. And in this video, we're still looking at ratios, but now let's see how we could graph them. All right, my friends, so you know before we begin, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. Remember, we're in volume 2. Second, you're going to need your math notebook so you can take those wonderful notes. Third, don't forget your pencil. And fourth, last but certainly never, ever, ever least, Mrs. Schlecht's most favoriteest material, that positive math attitude. All right, my friends, so this video goes very well with lesson 5-4, which of course is in your Envision volume 2, right? And what we're doing is, yes, we're still looking at ratios, but we're also going to be seeing how do we turn those ratios into ordered pairs that can then be graphed on a coordinate plane. Now, the key concepts for this lesson can be found on page 288. All right, my friends, so the first problem that we're going to be looking at together is actually example number 1, and it's on page 286. All right, here's what we got. Ellen is shopping for supplies at Jake's party store. She's going to have a little fiesta, great for her, right? Make a table to show how much Ellen would spend to buy 3, 6, 9, or 12 balloons. Then plot the pairs of values in a coordinate graph and use the graph to find the cost of 18 balloons, right? And then if we look over here, there's a picture in your book. It's like a little message board, and it's like a menu for what Jake's got selling in a store, right? Now, we know that balloons are 3 for $2. Hats are 5 for $3, and streamers are 4 for $1. Now, if we go back to our original problem, we're not talking about streamers. We're not talking about hats. I know they're festive, but that's not what we're talking about. We're talking about balloons, right? So this is the ratio that we are going to use to start building our table with more equivalent ratios. So over here, my friends, I've made a table of the ratios for our balloons, right? So when we have 3 balloons, that costs $2, and that's actually like our original ratio, right? And remember, the super duper cool thing, at least what Mrs. Schlecht thinks, is that when you have these equivalent ratios, all of them can be reduced to our original starting point, right? Our original ratio, super cool. All right, so 6 balloons, that cost $4. 9 balloons, that cost $6. 12 balloons cost $8. Now, I know in our original problem, it said I only needed to use the table to find out 3, 6, 9, and 12 balloons, like what those costs. But, you know, it also tells us we're going to have to figure out 18. So I just decided let's just make the whole table, okay? So then 15 balloons was $10, 18 balloons was $12, all right? So again, here are the different ratios, right? The different costs of a different amount of balloons that Ellen can buy. Now, you're probably wondering, Mrs. Schlecht, that's all and good, but it's talking about graphing, and this does not look like a graph. Well, you're correct. Now, there was someone in one of my classes, and I can't remember who, and I can't remember which class period, but said, hey, this is kind of similar to like an input and an output, right? Totally, those dependent and independent variables that we talked about a little while ago. And we also showed how you were able to graph those. Samesies over here, right? So when we're looking at how in the world do we graph this information, your input or the number of balloons, that's going to be your X coordinate, and the price, that's your dependent variable or your output, and that is going to be your Y coordinate, right? So now what I'm going to do is right next over here, I'm going to write what the ratio is if we use like our little colon dot, but then next to that, I'm going to be writing that ordered pair. So here's the new information that we've added to our table. The ratios, we could just write 3 to 2, 6 to 4, 9 to 6, 12 to 8, 15 to 10, 18 to 12, right? Again, I just got that same information from our table. But like we were just saying, your balloons would actually be your X coordinate because we can think about that as your independent variable, right? Or your input. And then the price is dependent on how many balloons you purchase. So this would be our dependent variable or our output, right? And the way that we can translate this to an ordered pair is over here. We would have 3, 2, right? So 3 would be your X coordinate, 2 would be your Y. 6, 4, 6 would be your X, 4 would be your Y. 9, 6, in this case, 9 would be your X, 6 would be your Y. 12, 8, 12 would be your X, 8 would be your Y. 15, 10, 15X, 10Y, and then lastly, 18X, and then 12Y, right? Now, here's also a super duper cool thing. do you know what the line will look like when you graph this ratio? Check it out. It's a straight line. Just like when we were graphing those independent and dependent variables, since these ratios are all equivalent, right? Since they all have that same relationship, when you graph them, and I know Mrs. Schlecht didn't actually graph them, just, pretend with me here for a second, my friends, it's going to be a straight line. And the really nifty thing about it is that once we actually graph this and we have that straight line going, we can use that graph to get information about multiple balloons. So what if I bought 51 balloons? How much would that cost? I'd be able to use my graph to figure that out. So my friends, again, we are able to turn a ratio into ordered pairs that can then be graphed on a coordinate graph. All right, so the next one that we're going to be looking at is number 4 on page 288. It says, complete the table to show equivalent ratios representing the cost of $8 for every 3 boxes. Then, write the pairs of values as points to be plotted on a coordinate plane. Something I want to point out to you, all right? So, in our problem, it says the cost of $8 for every 3 boxes. But you'll notice the table, this is what's also in your book, it has the boxes and then the price, right? Now, I know that it's a little weird because it's switched. That order is kind of flipped from the problem to the actual table. But remember, we're talking about those inputs, those outputs, those independent variables, and then those dependent variables, right? So this is actually the correct order that our table should go in, right? Because the number of boxes, that's independent. I can have more boxes, right? But what is dependent on the boxes? Well, how much I have to pay for those boxes. All right, so again, I know it's kind of the opposite of what's in our actual example or our directions, but think about it as our independent and then our dependent. That's the correct order that our table should be structured in or organized in, right? Okay. So over here, we have number of boxes, 3, 6, 9, right? And then the cost, $8, $16, $24. So this means when I have 3 boxes, that's $8. When I have 6 boxes, that's $16. And when I have 9, that is $24. Now, let's continue this table. All right, my friends, so now what I have done is I've completed that table, right? And I have these black lines right here to remind you how we're creating these equivalent ratios, right? We are using multiplication. And just like whatever I do on this side of my ratio, I also need to do on this side of my ratio to keep them equivalent, to keep that relationship staying the same, all right? So 3 to 8, 6 to 16, 9 to 24, that was our original starting point, okay? But here's our new piece. So I took 3, I multiplied it by 4, that's how we got 12 boxes. Now, how did we get $32? Well, that was 8 times 4, all right? Our next level of our ratio, we took our 3 boxes, multiplied it by 5. That's how we got 15 boxes. That costs $40. Why? Because 8 times 5 brought us to 40, all right? 18 boxes, that's our next level because we did 3 times 6. That got us 18. And that's $48. How do I know that? Because that was 8 times 6, all right? And then lastly, 21 boxes will cost $56. I know that because I multiplied 7 by my original ratios, all right? Now, we could continue this pattern forever, but I think we're good right here. Now, first step, done, right? We had to complete the table. I believe we have been successful at that portion of this problem. Well done, my friends. But the second part asks us to now create those ordered pairs. Remember, our independent, or the number of boxes, that's going to be your x-coordinate, and the price that's dependent on how many boxes you are going to buy, that is going to be our dependent variable, which will be represented by our y-coordinate. So my friends, we've now taken these ratios and written them as ordered pairs, right? All of the red are the numbers for our boxes. Again, that's going to be our x-coordinate. That's the number that comes first. And then the price, that's our dependent variable. That's our y-coordinate. And that number comes second, all right? So our ordered pairs, 3, 8, 6, 16, 9, 24, 12, 32, 15, 40, 18, 48. then 21, 56. And remember, if you actually graph those, it's going to create that straight line because they are all equivalent ratios showing the same relationship. So my friends, that was just a quick run through over how we can represent ratios with graphs on that coordinate plane. Pretty cool. Now, if you have any other questions, please let me know.